Hi, I'm Jonathan Cast and this is Global Script. So this is a follow-up to my last video. This whole thing that I was talking about in the last video is still confusing me. So I just want to go make another video to try to go through and explain it a little bit better. And maybe, hopefully, I'll get it clear in my own head. Anytime you have a program that's written in a global script-based language, you always have your program, and this program then is written in your program is written in the global script program calculus, which is part of global script, plus some language L. So then your program sits on top of the language L, runtime system, and standard library. And then you have a global script program calculus implementation sitting underneath all of that. So your program sits on top of both the global script program calculus implementation and the language implementation. Okay, so this is basically a picture for a compiled program. Right? So then, so your program is written in global script program calculus plus some language L. The language runtime system is generally written in a global script-based language called GSI. And then the global script, the GSPC implementation, is written in Haskell. So of course, in any program, there is global script, runtime system, has a GSI runtime system sitting underneath this language runtime system, which allows this global script program to call the functions from this GSPC implementation, which is written in Haskell. So when this is just doing global scripty stuff, it's just using the global script program calculus implementation directly as a global script program, the same way your program does. When this runtime system is explicitly talking to the global script program calculus implementation, it goes through this GSI runtime system. So then, if your program is compiled, then this is global script code. This will be translated to Haskell and then compiled. This will be translated to Haskell and then compiled. This is translated to Haskell and then compiled. This is written in Haskell, and then basically your compiled Haskell code is calling functions out of the global script program calculus implementation as Haskell functions. The compiled Haskell code here and here, your GSI runtime system, is written in Haskell. This is compiled global script code. So this is compiled to Haskell, and it's calling functions here and here directly. So this is written in true global script, so it can also be interpreted. What that means, part of the GSI, so there's a GSI standard library. Part of that is the code to read in a global script file. See, so if you've got your if your program is interpreted, there's an extra element that comes into play here. So you have, I'm going to just draw a big box here. You have your program. Your program sits on top of two boxes. You have, so your program is written in global script plus L. You have an L interpreter and an L runtime system standard library. So then the L interpreter is responsible for reading your program in and translating global scripts into something that can actually be executed at runtime, into bytecode, as it were. So your L interpreter, both of these are written in GSI. So your L runtime system is sitting on top of the GSI runtime system, or the, how do I want to put this? The GSI API. And then your L interpreter, which is also written in GSI, or GSPC plus GSI is what that means, is sitting on top of the GSI standard library. And the GSI standard library has a function which implements an interpreter, which does the interpreter, all of the interpreter things. So then the GSI standard lib GSI standard lib, so this is for an interpreted program. So the GSI standard lib sits on top of the GSI API, and then all of these things sit on top of the GSPC implementation. So there isn't, at least in the current implementation, there isn't really any distinction between interpreted code and compiled code as far as the virtual machine goes, or as far as runtime goes, or anything like that. They basically, compiled code is compiled to a Haskell data type, which is identical to, or a Haskell, not a data type, but a Haskell DSL, which is identical to the bytecode. It's just compiled through GHC. That DSL is compiled through GHC instead of having the bytecode objects created at runtime. So that's the only real distinction, is that the compiler takes the L interpreter, which we're assuming here is compiled, and translates it to bytecode that GHC then compiles, whereas your program is translated to bytecode at runtime that can't be optimized by GHC quite as well. But it's basically the same thing. So then, The third complication is when your L interpreter is not compiled but is interpreted. So now you have a GSI implementation, you have a GSI runtime system and standard library, all of which are now interpreted. So you've got a GSI interpreter. Now your GSI interpreter, like any other GlobalScript client, is itself written in GSI. It's almost the same thing. Well, it's very similar to the L interpreter. So now you've got this box, you've got your GSI API box, you've got your GSPC implementation. Your program is still running on this GSPC implementation because this is still what's doing all of the actual work. Your GSI interpreter is running on that. Your L runtime system is running on that. And your L interpreter is all running on this. And then so the other box, your L interpreter is also sitting on top of the GSI API, which it is using to talk to the GlobalScript implementation, the GSPC implementation. So this is fairly complicated. You've got GS values, which are part of your GSPC implementation. You've got GS values, which come from your compiled GSI interpreter and the code for it. You've got GS values from your your L runtime system. Your L runtime system is also sitting. This is written in GSI. Your L runtime system is also sitting on top of the GSI interpreter. So you've got GS values that are created by the GSI interpreter when it reads in your L interpretation and your L runtime system and standard library. And then you've got GS values and bytecode that are created by the L interpreter using the GSI API when it reads your program in. And so as far as these boundaries go, you've really got GS values which are in the GSPC implementation that are running the runtime system, the interpreter, and your program. But all of the GS values from these two, GSI wraps up in a wrapper GS value so that the GlobalScript code in GSI sees that GS value and sees its state as a first-class thing, not as part of its GlobalScript world. And the L interpreter and L runtime system have all of the GS values from your program. The L interpreter and the L runtime system wrap those up, not actually the standard library, but the interpreter and the runtime system wrap up all of the GS values from the L standard library, actually. The L runtime system is running on top of the GSI interpreter. The L standard library is sitting on top of the L interpreter and the L runtime system. And so all the GS values from the standard library and your program are wrapped up in an extra layer of indirection of an extra DS value for the L interpreter and the L runtime system to look at so that they can inspect their states. So there's only ever one extra layer of indirection that's involved there, which is involved with the interpreter and the runtime system for the program that's sitting directly on top of another system. So anyway, hopefully that was useful to you. I am Jonathan Cass. This is GlobalScript, and I am signing